If you have learned Python basics and still wonder, can I actually build something real? Today's answer is yes. In this video, we are building a smart calculator in Python, one that remembers results, doesn't crash, and handles mistakes like a real program. Welcome back to Bitwise Smarter, where Python stops being scary and starts being useful. Alright, here's your challenge. You are asked to build a calculator that behaves like a real calculator. Ask for numbers, let users choose operations, show the full equation, continue with previous results, restart cleanly, handle division by zero safely. This isn't just practice code, this is application thinking. Before we code, let's think like developers. A calculator is basically a loop that gets input, runs logic, prints output, asks what to do next, and we'll build it using a clean pattern. Functions for each operation, a dictionary to map symbols to functions, loops to keep the calculator running, and safety checks for real world mistakes. Now let's look at the code. Step 1. Write the math functions. We create one function per operation. Each function does one job. So for add, this takes two numbers and returns the sum. Similarly, we have functions for subtract, multiply, and divide. For divide, we use a safety net. This is important. If someone tries to divide by 0, Python normally throws a zero division error and crashes. But we are not building a fragile calculator. We are building a smart one. So we check if n2 equal to 0 first and return a friendly message instead. Step 2. The operations dictionary. Now comes one of the coolest beginner to intermediate tricks. This dictionary connects symbols to functions. Instead of writing a long chain of if-elif, we let Python select the correct function for us. Think of this like a menu. You choose the symbol and the kitchen executes the recipe. Step 3. Start the calculator function. Now we wrap everything inside a main function called def calculator. This is our main app. Step 4. Add a restart loop, the outer loop. Now we add a loop whose job is to restart the calculator whenever the user chooses. This outer while true is the restart engine. Every time we restart, we ask for a fresh first number. Step 5. Add the continue loop, inner loop. Inside the restart loop, we add another loop. This second loop handles continuous calculations with the current result. So now we have outer loop for restarting, inner loop for continuing. Next up, show operations and get inputs. Now we show users what operations are available. This is nice because it auto updates if you add new operations later. Then we ask the user to pick one and enter the next number. Now choose the function and calculate. Here's where the dictionary becomes powerful. We grab the function using the symbol and call it. Then we print the full equation. Now we handle the division by zero case. In our divide function, if someone divides by 0, we return a message string. So we detect that. If the answer is a string, it means it's not a real numeric result. So we break out of the inner loop and the outer loop restarts the calculator cleanly. Finally, we look at continue, restart, and exit options. We ask the user what they want to do next. This gives the user real control, like a real app. If they choose Y to continue, we reuse the previous result as the next first number. If they choose R, restart, This breaks out of the inner loop only, which triggers the outer loop to restart. If they choose N to exit, this return ends the calculator function completely and the program terminates. Here's a key programming concept. Break exits the current loop. Return exits the function. Nested loops help you model real application behavior. This is how beginner scripts become real programs. Alright, here's the full updated code in one piece. Let's run it. Here are some quick tips to level up this project. Validate the operator input so only addition, subtraction, multiplication, and division are accepted. Use a try except for invalid number inputs like ABC. Add new operations like power or modulo. Add a history list to store past equations. Same pattern, bigger projects. Similar projects using the same logic. This is the most important mindset shift. You didn't just build a calculator, you built a reusable pattern. Let's look at some examples. Smart restaurant bill splitter. Same exact structure can build a bill splitter. Add item prices, apply tax, add tip, split between people, continue, restart, or exit. Your functions change, but the loop plus dictionary pattern stays. Another example is a productivity time tracker. Add work sessions, subtract breaks, show total minutes or hours, restart for a new day. Same logic, different purpose. If you build this calculator, congratulations, you have crossed the beginner threshold. Like this video, subscribe to Bitwise Smarter, and try extending this project. Change the functions, reuse the structure, build something personal. I'll see you in the next one. And yes, your calculator will keep judging your math.